After studying this module, you shall be able to understand the relationship between total product and marginal product, understand the relationship between marginal product and average product, know the reasons behind the shape of these curves, learn about the implication of the law of diminishing marginal product, identify the three stages of production, learn how to estimate a production function using OLS regression. In the previous module, we introduced the concept of a production function and learned that the aim of the producer is to produce output by using a mix of inputs in the most efficient way. Recall the production done by a producer can be defined as an activity which combines inputs or factors of production, that is goods and services, with the production technology to make other goods and services which are known as outputs. Production process. Inputs get transformed into output. So, the production process is defined as a transformation of a set of inputs into a number of outputs. We also saw in case there is only one variable input, then the diminishing marginal returns sets in for the variable factor when its quantity is increased, holding the fixed factors constant. This was the law of diminishing marginal returns introduced in the previous module. This law helps to explain the shape and relationship between total product, average product and marginal product, the concepts we discussed earlier. We also introduced the shapes of the three curves via a numerical example. The relation between TP, AP and MP is further explained in the next section. This will be followed by a discussion on the various stages of production based on the application of the concept of diminishing returns. Thereafter, in the final section, we will discuss how to estimate a production function with a single variable input using standard econometric techniques. Relationship between total product, average product and marginal product. From the discussion below, you will see that there is a certain relation that holds between TP, AP and MP curves. The AP curve rises initially and declines thereafter, but remains positive as long as TP is positive. The MP curve rises initially, it is 0 when TP reaches a maximum and it is negative thereafter. When the AP curve rises, the MP curve is above it. When the AP curve falls, the MP curve is below it. And when AP attains a maximum, MP is equals to AP. We will use the following production function to demonstrate this relation. Q is equals to 60L square minus L cube. This production function has a single variable input which is L, which is used in combination with the fixed factor K to produce output Q. This was introduced in the previous module and it will now be used to explain graphically the relationship among TP, AP and MP curves. Note that the TP curve is rising consistently till L is equals to 40 and then declines at figure 1 below, whereas the AP increases and then falls much before L is equals to 40, which is given in figure 2 below. At the point L is equals to 40 where TP is maximum, MP is 0 and after this it becomes negative, which is given in figure 1. While AP rises, MP is greater than AP, given in figure 2. In this phase, MP rises, reaches a maximum, then starts falling and intersects AP from above. A point comes where AP and MP are equal. This occurs at L is equals to 30 where AP is maximum. And after this point, the AP curve starts decreasing. When AP is falling, MP is less than AP. Both AP and MP are inverted U-shaped curves. This result occurs for every production function that exhibits the diminishing returns to the variable factor. We will now discuss separately the relation between TP and MP as well as that between MP and AP in section 3.1 and 3.2 respectively. 3.1 Relationship between TP and MP. The relationship between TP and MP can be classified into the following three phases. First, phase 1, increasing marginal returns. Second, phase 2, diminishing marginal returns. Third, phase 3, diminishing total returns or negative returns. Figure 1, relationship between total product and marginal product of labor. Phase 1, increasing marginal returns. This phase is known as the increasing marginal returns because in this phase marginal product curve is increasing as more and more L is employed. In this phase, as MPL increases, the TP increases at an increasing rate, that is, TP is convex in shape. Phase 2, diminishing marginal returns. In this phase, MPL starts declining as more and more L is employed. This is why this phase is known as that of diminishing marginal returns. When MPL is declining, the TP increases at a diminishing rate, that is, TP is concave in shape. Note that when TP reaches a maximum, MPL equals 0. Phase 3, diminishing total returns or negative returns. In this phase, TP starts declining after reaching a maximum and MPL becomes negative as further units of L, that is, more than 40 units of L are employed. 3.2, relationship between MP and AP. The relationship between marginal product and average product of labor can be classified simply in two phases. Figure 2, relationship between marginal product of labor and average product of labor. Phase 1, marginal product is greater than the average product. In this phase, as long as MPL is greater than APL, APL is increasing. When APL reaches a maximum, MPL cuts APL from above and the two are equal. Phase 2, marginal product is less than the average product. In this phase, MPL is less than AP and AP declines. The entire discussion above has set the stage for explaining further the implications of the law of diminishing marginal returns. This extremely important law of production theory can be used to explain the inverted U shape of the AP and MP curves and further to classify the process of production into three stages. The next is stages of production. Law of diminishing marginal product. Features and assumptions. The law of diminishing marginal returns or marginal product that was introduced at the end of the previous module essentially explains how output will change in short run when one variable input is changed, keeping all other factors of production unchanged or fixed. This law is also known as the law of variable proportion. This has been defined by various eminent economists who have contributed most to our understanding of this concept as follows. According to G. Stigler, as equal increments of one input are added, the input of other productive services being held constant, beyond a certain point, the resulting increment of product will decrease, that is, the marginal product will diminish. According to F. Benham, as the proportion of one factor in a combination of factors is increased, after a point, first the marginal and then the average product of that factor will diminish. According to Paul A. Samuelson, an increase in some inputs relative to other fixed inputs will, in a given state of technology, cause output to increase, but after a point, the extra output resulting from the same addition of extra inputs will become less. The law of diminishing returns is based on the following set of assumptions. First, constant technology. This law assumes that technology does not change at all through the process of production. Second, one variable factor. One factor, example, labor is variable while others are fixed. Third, variable proportion. The proportion of the inputs used in the production process is not fixed and it can vary. Fourth, this law operates in only short run. Fifth, each unit of variable inputs used in the production process are considered to be equally efficient. The next is 3 stages of production. We will now use the short run quadratic production function introduced in the previous section to demonstrate how, based on the law of diminishing returns, we can identify the 3 stages of production. Tp is equals to Q is equals to the function of labor and capital, where capital is held constant, is equals to FL is equals to 60L square minus L cube. This is equation 1. The total output obtained and the corresponding values of average and marginal output levels are tabulated below in table 1. Assuming that the firm employs 1 unit of capital and increases the employment of labor starting with 0 units and going up to 56 units. Based on the behavior of the total product, the entire production process can be divided into 3 stages, as the producer makes changes in the variable factor, combining it with the fixed factor whose quantum remains unchanged. These 3 stages of production are as follows. Stage 1. Stage of increasing returns. In the above figure, it has been shown that in this stage, the total product curve, that is Tp curve, increases at an increasing rate from the origin to point A. Or in other words, the slope of Tp curve is increasing up to the point A. That is, Tp curve is convex in shape. This is due to the fact that MP of the variable factor, labor, is rising up to point B. That is, up to point A on the Tp curve and point B on the MP curve, the incremental or additional output obtained by hiring an extra unit of labor increases. After point A, the Tp curve rises but at a diminishing rate. That is, Tp curve becomes concave in shape. Beyond this point, the slope of Tp, that is MPL, declines even though it is still positive. So, MPL starts diminishing once the firm employs labor beyond 20 units. Beyond 20 units of labor, the additional output obtained diminishes as 1 more unit of labor is employed. That is, the law of diminishing marginal returns starts operating in stage 1 after point B on the MPL curve corresponding to 20 units of labor units employed. This stage ends once the APL curve reaches its maximum at point C, when 30 units of labor are employed. Note that from point B to C, MPL is falling, but it still exceeds APL, and this is what leads to a rise in APL curve continuously up to point C. At C, MP cuts AP from above and the two are equal. Stage 2. Stage of diminishing returns. In this stage, the Tp continues to rise at a diminishing rate until it reaches its maximum point D, where 40 units of labor are employed. This stage ends at point D. Throughout this stage, MP is diminishing. That is, the law of diminishing marginal returns is operating. Note that both MPL and APL curves decline in this stage, however, both remain positive. Also, note that when AP is declining, MP is less than AP. Finally, another important point to note is that at the end of this stage, that is at point E, MPL becomes 0 when the TP curve attains a maximum at point D. Stage 3. Stage of negative returns. This stage sets in after point D when the total output starts diminishing with increase in labor input beyond 40 units. Clearly, there are far too many units of the variable input at this stage given the fixed amount of the other input, that is capital in this case. That is, in this stage, increase in the variable factor leads to a downward sloping TP curve. Note, at this stage, MPL, which is the slope of the TP curve, is negative, and that is why this stage is known as the stage of negative returns. An important question to be asked here is at which stage should a rational producer operate? To answer this question, let's start with stage 3 and ask, will the producer operate in stage 3? Note, a rational producer will never choose to operate in stage 3 where MPL is negative. This is because he can always increase output by reducing the amount of variable factor employed rather than produce at this stage. After all, the producer can always stop hiring labor at the end of stage 2, where MPL is equals to 0 and where he will maximize TP. This way, he can achieve the maximum utilization of the variable factor, which is labor in this case. Now consider stage 1. A rational producer will never operate to left of point B on the MP curve or to the left of point A on the TP curve. This is because up to point B, MP is increasing and correspondingly output is increasing at an increasing rate. However, after point B, MP is diminishing even though AP is still increasing. This indicates that the fixed factor is still relatively underutilized, as by hiring more variable input, there is a scope for increasing the average output further. If the wages payable to the labor is less than the APL, then the producer would increase production by hiring more labor at least till the point C, where APL is maximized. So, at this point, the fixed factor is, in a sense, being fully utilized. In fact, the producer can also decide to produce in stage 2, where AP and MP are declining, but MP is still positive. The price of the variable factor will be the deciding factor for the number of units of labor hired and hence for the exact point of production in this stage. You will have a clearer idea about the optimal production decision of firms once we introduce the notion of cost of production and firms' decisions to maximize output while minimizing the cost of production in the next module. Note that throughout this analysis, we assume that the producer faces no demand constraint. That is, once he decides on a level of production, he does not face any problem selling the output in the market. So far, we saw how the law of diminishing returns, also known as the law of variable proportion, helps to understand the production process. In the next module, we will introduce two variable inputs. We will also introduce the input cost and explore firm's production decision in this context. The next is production function estimation. So far, we have introduced a production function with a single variable input. We specified some functional forms of production functions in the previous module, such as a simple linear production function, which is Q is equals to A into L, a production function with diminishing returns, that is Q is equals to A into L to the power B, where 0 is less than B is less than 1, etc. Firm level data on production, that is Q, and on the unit of variable factor, that is L, employed as given in table 1 above, can be used to estimate a production function using the ordinary least square, which is also known as OLS regression model. The estimated coefficients would provide important insights into the nature of firm's production process. For example, whether or not there is diminishing factor returns and so on. In what follows, we will use a particular example to demonstrate how this can be done. Consider a cubic production function given by Q is equals to A into K cube into L cube plus B into K square into L square. This is given as equation 2. In short run, we consider K to be fixed factor which is held constant at K hat units, and L is the variable input, so that this function becomes Q is equals to K hat cube into L cube plus B into K hat square into L square, or Q is equals to A into L cube plus B into L square, where A and B are both in capital in this case. Here A is equals to, that is capital A is equals to A into K hat cube, and capital B is equals to B into K hat square, and both capital A and capital B are constants. Note, for this production function, APL is equals to AL square plus BL, and MPL will be equals to 3 into AL square plus 2BL. From the first order condition for maximization of AP and MP, we obtain MPL is maximized at L is equals to minus B by 3A, after which diminishing marginal returns sets in. APL is maximized at L is equals to minus B by 2A, after which APL starts to decline. Note, the above is subject to the condition that A is less than 0, that is, small a is also less than 0, where capital A is equals to small a into K hat cube, and B, that is capital B, is greater than 0, that is small b is also greater than 0, where capital B is equals to small b into K hat square. Now, suppose there is a small plant producing a certain good, and the manager would like to estimate the production function as well as the marginal product of labor. To estimate the cubic form of the production function, we transform the cubic equation 3 into the linear equation, that is Q is equals to AT plus BV, where T is equals to L cube and V is equals to L square. Since this cubic function did not have an intercept term, we estimate a constrained OLS model without a constant term, so that the regression line passes through the origin. The model is estimated using 40 observations, and the following coefficient estimates are obtained, which are given in the following table. From the low p values, it is clearly evident that both the variable t and v are statistically significant at the 1% level of significance and have the expected signs. So, the estimated cubic cost function is Q hat is equals to minus 0.0047 into L cube plus 0.2731 into L square. From this, we can obtain the marginal product of labor as follows, assuming K hat is equals to 1. MP hat is equals to 3 into A hat into L square plus 2 into B hat into L, which is equals to 3 into minus 0.0047 into L square plus 2 into 0.2731 into L, which is equals to minus 0.014 L square plus 0.5462 L. From this, we can calculate the level of employment after which the diminishing marginal return sets in is L is equals to 19.36. We can estimate average product of labor as follows, assuming K hat is equals to 1. AP is equals to A hat into L square plus B hat into L, which is equals to minus 0.0047 L square plus 0.2731 L. Can you calculate the level of employment at which APL is maximized? Hint: this occurs at L is equals to minus B by 2A. The model has a high R square, indicating that the cubic production function is a good fit for the given data for the firm. Also, we find that this production function displays the diminishing marginal returns to labor. Summary: let us now learn what we have studied in this module. The production function requires both fixed as well as variable factors to produce output. The shape of TP, AP and MP differs in the different stages of production. When marginal product is greater than the average product is increasing, and vice versa. When average product is at its maximum, marginal product equals average product. When total product is maximum, marginal product is 0. The law of diminishing returns, which is also known as the law of variable proportion, states that after a certain point, when additional units of a variable input are employed, holding the level of fixed inputs unchanged, the marginal product of the variable input declines. The law of variable proportion can be used to identify the 3 stages of production in the short run. Simple OLS regression technique can also be used to estimate a production function.